Assalamualaikum everyone and ma'am. My name is Ahmad Hakim Berisham, 2240231. So today I'm going to present about concepts of computer graphics. So there are five concepts that I'm going to talk about today. The first one is shaders, two buffers, textures, rendering pipeline, and model view projection. So what are shaders? Shaders are small programs that run on the GPU and then control how graphics are processed and rendered, including how objects look, how lighting interacts with surfaces, and how colors and textures are applied. The common types are vertex shaders, pixel shaders, and geometry shaders. So, what is the purpose? Shaders let developers control how graphics are drawn, enabling effect like lighting, shadows, reflection, and water ripples. And it also allows realism and creativity in graphics. So, for example, in games like Call of Duty or Fortnite, shaders are used for realistic water reflections, dynamic lighting, and special effects like explosions. And in VR and AR, shaders simulate realistic materials like metal, glass, and skin. So, this is the illustration for shaders. On the left, we have the vanilla, means the original one without shaders, and on the GGX, uh, the shaders is applied on the gun. You can see the reflection and the water reflection. And up next is buffers. Buffers are memory storage areas in the GPU that hold data needed for rendering. They store information like vertex positions, colors, normals, and texture coordinates. So there's three buffers: vertex buffer, index buffer, and frame buffer. What are the purpose of buffers? Buffers efficiently store and manage large sets of graphical data on the GPU. It prevents recalculating the same data repeatedly and it's essential for handling complex 3D worlds with thousands of objects. So, for example, in Minecraft, vertex buffers store cube positions. Without buffers, every block would need recalculation, making the game extremely slow. And it also explains how Minecraft have an infinite range of distance in the world. And in simulation like flight simulators, buffer store terrain, vertex data for smooth rendering. So this is the illustration of buffer, frame buffer, like the one before, frame buffer. So what are textures? Textures are 2D or 3D images applied to the surface of a 3D object to give it a detail and realism. Instead of modeling every detail, a texture map can be wrapped around geometry like wrapping paper around a box. So, what is the purpose of textures? It adds detail without adding extra geometry, so it's faster and more realistic. And they simulate wood, stone, grass, skin, and enable realism. For example, in GTA 5, textures give building bricks, walls, and roads and asphalt surfaces. Same as in VR and AR medical simulations, skin textures on virtual to make them lifelike. So this is one of the illustrations in GTA. You can see that on the old one, there's no applied textures, and the new one it looks much more realistic than the old one. Same as the one on the top left picture. So rendering pipeline. The rendering pipeline is sequence of steps the graphics data goes through to be transformed into pixels on the screen. It involves stages like application stage, geometry stage, rasterization stage, fragment and pixel processing, and output. What is the purpose of rendering pipeline? It converts abstract 3D models into final 2D images on screen, organizes graphic of operation into stages for efficiency, and ensures consistent rendering across different GPUs. So, an example in Unreal Engine or Unity, the rendering pipeline shows objects are drawn in the right order with lighting and effects. In AR apps, pipeline ensures virtual objects are blended correctly with real-world camera feed. So this is one of the pipeline in Unreal Engine, same as the one on the right. It's like a steps for something to be made into an output. Number five, model view projection, MVP matrix. So the MVP matrix is a mathematical transformation used in 3D graphics to position objects correctly in a scene. It combines three matrices. So first one is model matrix, two view matrix, and three projection matrix. So what is the purpose? It ensures 3D objects are positioned and oriented correctly relative to the camera, and it allows scaling, rotating, and moving objects realistically and enables perspective. For example, in VR games, MVP ensures objects move correctly when you turn your head. In car simulators, MVP transform a 3D car model so it is right placed on the track. So this is the illustration. You can see the camera world, and that's how we view the 3D car. So that is all for me. Thank you.